This is the recording for my third research paper, and the title of this paper is An Innovative Approach for Ad Hoc Network Establishment in Disaster Environments by the Deployment of Wireless Mobile Agents, and the authors, the location, and the date of publication are shown on the slide. So first responders are crucial parts of disasters because they're required on site. And to assist them, ad hoc networks are established through the implementation of wireless mobile robots. However, this is a complex task because wireless mobile robots are limited with their capabilities. There needs to be assurance that the robots can communicate within a network, as well as cover maximum areas in a disaster's environment, and also the maximum number of task locations. With these wireless robots, with them establishing these ad hoc networks in the complex environments, first responders can perform their tasks efficiently. These wireless robots have been researched for over 10 years with the attempt to efficiently establish an ad hoc network quickly, scalably, and also with low infrastructure dependency. The robots undergo search and deployment to discover and cover the maximum stationary tasks. The problem is that the implementation of search and deployment is yet to be optimized for small or large disasters, and communication that is low in power consumption and doesn't really require satellite dependence, and also doesn't limit the robot's capabilities. So because of this, there is still some improvements to be made when implementing these task-based mobile robots, search and deployment systems. So research has taken place to develop information collection within different environments, as well as routing and navigation of the wireless robots in unknown and complex environments. Ad hoc approaches came about when wireless technology was developed, and it allowed the proposition of models such as the Self-Organization Framework for Robots by Gu et al., which allowed for boundary coverage based on artificial gene regulatory networks. Other approaches such as flocking-based distributed deployment approach was made for stationary and mobile sensories that could deploy sensors around a specific target, and this was by Tu et al. So the previous researchers aimed to cover an area of the environment based on assumptions that there are sufficient sensors, but this assumption was not considered by this paper as it didn't seem fair. And as stated in this paper, prior research of sensors leads to an uneven distribution of tasks, and this may lead to sensors being unable to communicate with each other. These differ from this paper's research proposal because they attempt to base the deployment process on an enumerating process. And this can essentially find the optimal deployment locations for wireless robots to maximize the objective's value. So task-based wireless mobile robot search and deployment approach aims to establish ad hoc networks in disaster environments to help first responders. The wireless mobile robots, they can collect information in an efficient manner under uncertainty of a complex environment, and they can also consider the communication of the robots, coverage of the tasks, and coverage of the environment to create an ad hoc network. The proposed solution allows the wireless robots to handle uncertainty of the environment, because in a disaster there can be varying environmental uncertainties. Also complexity of the environment, because obstacles in a disaster environment can impact on the search path, and it can also eliminate certain potential deployment locations of the robot. And then another thing is the limited number of wireless robots, because road blockages can lead to only a limited number of robots entering the environment. And then a workaround this is having a large amount of stationary tasks distributed within the environment. The requirements to achieve an efficient task-based wireless mobile robot search, there should be an enablement for the robots to efficiently collect information as well as communicate in the established network so that successful information sharing regarding stationary tasks and first responders to other robots within the network. Maximum coverage of task locations, as stationary tasks may not be distributed evenly. So there should be a system in place to ensure that most of the tasks can be performed. Also maximum coverage of the environment, because first responders, they need guidance from the wireless robots. So the ad hoc system should communicate with the maximum area of the environment. The image on the slide shows the proposed approach's principle, as the search process strategizes and checks the remaining energy of a robot and its movements to collect information about the environment, alongside deployment process, which updates the current location and the next suitable location, to then implement the A* search algorithm to create new paths. So other approaches mainly focus on routing or navigation in unknown and complex environments, but this leads to an inefficient search strategy in terms of collecting information. They also mostly deploy the robots to establish an ad hoc network, but they do it in a centralized way, and this can consume lots of time and resources. Not only this, but the network that has been established couldn't achieve communication, maximum coverage of task location, as well as maximum coverage of the environment. And so it basically limits its efficiency and effectiveness in terms of disaster rescue. The proposed search process implements a search algorithm to create paths within a map from one location to another, and this algorithm is shown in the image. The deployment process continuously calculates the most suitable deployment location based on the information collected in the search process. Paths are continuously created based on what is most suitable, and the search process guides the wireless robot to collect as much information of the environment using the search strategy module, which implements a mean shift algorithm, as well as the A* algorithm to create paths, and the movement checking module checks the remaining energy of the robot, adjusting paths and movements accordingly. The deployment process happens during the search process to help the robot find the most suitable deployment location. And this is done through the implementation of deployment location finding with 2 points and deployment location finding with density graph. And each of these come with their own computational complexities, such as the big O 2 times n times n for deployment location finding with 2 points, because all the potential locations are calculated from the combination of the 2 locations. The first experiment that was conducted was to compare robot sensor deployment with task-based wireless mobile robot search and deployment. And the result was that the task-based collected more information about the tasks compared to the robot sensor deployment. And this is actually because the task-based can move to locations that cover the maximum tasks in the area. The second experiment was to test the coverage of tasks and environments of the wireless robots that are deployed according to, firstly, the dynamic relay deployment, and this is proposed by Go et al. And then secondly, the deployment location finding with 2 points, and thirdly, the deployment location finding with density graph. And just to recap, that the dynamic relays deployment doesn't actually consider communication ranges of the robots, and it requires the use of satellites to coordinate with each other, which is different to the other two. And the result of this experiment was that the dynamic relays deployment based approach always found locations with maximum task coverage globally to deploy robots, but deployment location finding with 2 points and deployment location finding with density graph could only find locations with the maximum task coverage near the deployment locations of the robot, so locally. And then the third experiment looks into local views, So this is basically the robot's task coverage with deployments based on the task-based wireless mobile robot search and deployment, and the dynamic relays deployment with local view. And the goal is to test which has better task coverage on the environment. The results of this experiment was that the robot deployed based on task-based with local views can cover just as many tasks as the robot deployed based on the global view about the environment. So there were no changes there. The task-based approach seems to enable robots to collect information efficiently in an unknown and complex environment. The experiments show that the task coverage and environment coverage was considered, and that the ad hoc networks established by this approach had better performance than the current approaches. In the future, they plan to handle dynamic changes of the environment, and this can be useful during a disaster rescue because new tasks arrive as the old ones are being completed, and it makes it really difficult for the network to satisfy requirements on the disaster. Another factor that is still unsolved is the adaptation of the deployment locations of the robots based on their current task distribution. So these are future adjustments that need to be made and considered.